All right, so what if you had shoes to add to your outfit from before? Okay, say now we had two different pairs, a black pair and a red pair to go with your black and blue jeans and tan and yellow and blue shirt. Well, okay, well, we're going to start with same kind of thing we had before. We had our jeans, then we had three shirts each, and then from each shirt, we can either choose black or red shoes. And so then what happens is we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if we think about that, what did we do? We multiplied all the values together. We took the 2, go back, the 2 times the 3 times the 12, or times the 2, and we got our 12. So we just took 2 times 3 is 6 times 2 is 12, and that's how we did it. Because we took here to here, we took 2 times the 3, and then from here to here, we had two more choices. So we took that times 2 and multiplied all together. That gave us 12. And again, just add up the last row here, and we see that there's 12. So moving that to extend the fundamental counting principle to determine the number of outcomes in a situation where there are three or more items. Notice I say or more. Basically, the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So we could have, three, like we just found. We have M, N, and O. So we could take 2 times 3 times 2, and we got 12. Or we could even have more. We could, every time we have a thing, we could figure out, well, how many ways there was to do it. And then we just have to multiply each of those together to get our final number of ways. Okay. And so that's how we're going to use our fundamental counting principle. So here we have a pizza can be ordered with two choices of size, medium or large. All right. So here, if we're doing this M, we're going to say, well, there's two possible ways of that. Three choices of crust. So N is going to be three. And five choices of topping. Well, let's call it T. And there's going to be five ways of that. So if we take M times N times T, that should give us the number of different one topping pizzas that there are. So that's just going to be 2 times 3 times 5. Well, that's 15 times 2. So that's going to be 30 ways to choose one topping pizzas. Okay. What about this one? So we have a car manufacturer and they're experimenting with lightweight three-wheeled cars designed for one person and considered ideal for city driving. Intrigued? Suppose you could order such a car with a choice of 10 colors. Okay, so let's see is 10. With or without air conditioning, so we'll call that A, so that's 2. Electric or gas, so power is two possibles. And with or without a computer. And so we already did color, so we'll do a computer with a K. And so there are two possible ones. And now, furthermore, the car is available with or without a global positioning system to pinpoint your location at every moment. Well, let's call that G for GPS. And so there's two possible ways with that. Now, how many ways can this car be ordered with regard to these options? So basically, we're going to take C times A times P times K times G. And so that's going to be 10 times 2 times 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 4 is 16. 16 times 10 is going to give us 160 ways that we can actually do this. Okay. So that's how we can do it with multiple. We looked here with 3, here we had 5. Okay, so there's 5 possible things we had to look at to get this final options for our car that we're going to order. All right, so let's stop there and we'll come back for more.